Hey, howdy. This is the first video in a series that I've been planning on doing for a long time. And unlike a certain other project that's probably going to take way longer than I thought, since as it happens, scripts for video essays take a really long time to write, I don't need over 50 videos worth of research to cover it. I also decided against making this an edited video, and I think I'm going to hold with that for this whole series. I got a good chunk of the way through editing the video and then kind of just realized that I wasn't having fun. I have more fun when I'm riffing off script like this. And I have a script in front of me just so that I know that I'm decently on track, but I don't know. I like the live performance aspect a lot more than the edited video aspect. But for this, I don't need any sort of editing software. I just need a copy of Bejeweled Deluxe and a way to code in Python. So let's make some artificial intelligence. So anyone who's seen a long PopCap video of mine, specifically the Noah's Ark one, knows that I really like AI and I also really like teaching people about AI, but the trouble is that general education regarding CS, or computer science, is terrible. It's just really, really bad. And it's left an entire generation of people kind of just assuming that AI is this big metal box, and then you feed it in any instruction, you just talk to it directly like you would Siri, and through the power of friendship, electricity, big data, and science fiction, it will just do those things for you. Well, that's not really how it works. AI is a weird topic because it's such a broad term that it's really hard to define. Anything from Google Translate to ChatGPT to GPS or even something like Deep Blue, or a function solver on the calculator, could technically be called AI. Oh, that's a bug. Hang on. Let me restart this. There we go. And any kind of program that implements an algorithm like that could technically be called an AI, and it wouldn't necessarily be wrong. The definition I always heard was that an AI is a program that takes in an external source of data, processes that information internally, then uses those calculations to produce an output externally. And we could argue all day over whether that definition is correct. Rambling on about definitions and the ethics of not properly teaching people about this stuff aside, though, what exactly am I planning to do here, or what have I already done here? Well, my goal was to make a program that automatically played Bejeweled Deluxe for me, and I also wanted it to do a decent job. If you couldn't tell by now, that's not me playing. That's actually a script that I wrote in Python. I didn't necessarily care about perfection, but I wanted it to do a pretty good job, and I wanted it to beat my scores, and it actually did. You'll see eventually when it loses, the entire leaderboard is full of this bot's scores. It's insane. I'll go over the rules of the game. You might be able to tell just by looking, but just for posterity's sake. And then I'll dive into the process of designing the program itself. I'll try my best to... I know that there's a Visual Studio open right now, but I'm going to try my best to keep things understandable to people who normally don't do CS stuff, because, like I said, good CS education is hard, and it's also really sparse, and what kind of a teacher would I be if I just dropped a stack of terms in your lap, expecting you to be able to understand 4 years worth of computer science jargon? That's just not how I roll. The game itself is extremely simple. This was PopCap's first widely published game, after all, besides Foxy Poker, which doesn't count. It was designed from the get-go to be really easy to pick up. There's an 8x8 board made up of 7 different types of gems. They can be differentiated by their shape and their color, and matching 3 in a row along cardinal directions will remove the gems from the board and give you points. The game continues like this until you either level up, which shuffles the board, or until you run out of moves, ending the game. Time Trial has slightly different rules, because when you run out of moves, instead of ending the game, it will just shuffle the board and let you keep going. In that case, it keeps going until you run out of time, which will give you a game over in the same way. Unlike newer versions of Bejeweled, there are no fire gems, lightning gems, hypercubes, fruit gems, or microtransaction-based power-ups. There's just you and your board of gems, and you gotta work with it. Also, an important note before we go any further. My plan for this project was to avoid poking under the hood as much as I possibly could. I want the game and the program to run completely independently of each other, so getting the array of gems directly from the game is not allowed, and this goes for this project and all future projects. So, how do you build an AI? It seems super harrowing, but this one's actually pretty simple. Every time I wanted to make a move, I followed this set of steps. Step 1, take a snapshot of the current board. Step 2, find all possible moves within that snapshot. Step 3, pick a move and perform it in-game. Step 4, wait for the animation to finish. And then Step 5, go to Step 1. And just repeat that over and over and over again. First, let's cover the snapshot step. Hang on, let me turn off the player real quick. I was tempted to literally take a screenshot of the entire screen and go off of that, but that ends up being really, really slow. I don't remember the resolution of my laptop screen exactly. It's something like something close to 1920 by 1080. Not exactly, but it's close to that. Ah, there it goes. Yeah, look at that. I got the highest score for the day. Oh no, look at the scores. The scores are a little ridiculous. So first let's cover the snapshot step. Let me close this out and open up trusty Microsoft Paint. So taking a screenshot is out of the question. Instead, we'll start by finding the position of the window. And then from there, we search for a pivot point. The pivot point that I went with is the right edge of the Bejeweled logo. Like if I go back into normal mode, I would start with the Bejeweled logo. I would move a little bit right until I'm hovering over the first gem, and then I would scan down and then across. And from there, I could get an exact grid of all of the gems. But I mean, I'm glossing over a pretty important detail. How the hell do I actually get the gems? Well, my first thought was the way that I got the position of the logo is there's a function. Let me see if I can. It is this one right here. This package, PyAutoGUI, it's stuff like mouse movement, simulating key presses. It's stuff that's used to control what would normally be user input. It also has functionality for taking a screenshot and locating stuff on the screen. This was originally what I was going to use for the screenshot. Instead, jeweled.png is that picture of the logo, and I just plug it in and I find it. I was planning on doing the same with the gems, but I ran into a bit of an issue where locate all on screen kind of sucks. What it does is, suppose that you have an image of some size, it will go basically pixel by pixel across the entire screenshot, the entire screen, looking for that exact array of pixels. And when it can't find it, it will keep going until it finds the very first thing that's below a certain confidence value. Well, the problem is that is very, very likely to produce false positives and false negatives, and any amount of false positives or false negatives will completely derail this project. If I don't have 100% accuracy, this system is going to mess up, and it's going to be so much worse than a human player. So what I ended up doing instead is, like I said, what I could do is once I had the position of the Bejeweled logo, I can move a little bit to the right, and now I'm hovering directly over the gem. So what I did is I just got the pixel value of all of the pixels, or all of like the centers of each of these gems, and compared it with a chart that had all the hues on them. And for instance, this is an orange. It has some range. It's got to be like 20 or something, because red is 0. It's either 20 or 25, somewhere around that ballpark. I plug it into the system, and if that hue is 25, then it puts an orange on the board right here. Now, naturally, it's not perfect in this state because the gems are not perfectly colored the same hue all the way across. But what I did instead is I just took, instead of getting 1 pixel, I took a 5x5 grid and then averaged out their color, and that worked out really well. me see if I can find that bit in the code. There you are. Oh, right, I forgot about this. So R is actually my failsafe. But all these other ones, you'll notice the values. I was actually really close. 22 is what I ended up going with for orange. And you have 60 for yellow, 111 for G, for green, not G, 200 for blue, 300 for purple. White is a weird case because it's hue. If you don't know what hue is, it's instead of directly mapping the red, green, and blue values, it's mapped to a color wheel. So white ends up being mapped to exactly 0, or very, very close to 0, because it's just black and white. And oftentimes, when there's no hue at all, it gets mapped to 0. And R ends up just being the last case there. So now that that's done, there is something that I do want to mention, because this works mostly. But you might notice whenever I make a match, that creates text, and that text flies directly in front of the gems. So there's a good chance, whenever I run this, that it will get decalibrated. It doesn't last for very long, but especially when I start to decrease the time between moves, it becomes very obvious that the system is getting confused. So now we have a two-dimensional array of all the gems in the current board, and we have it process internally. Next, we have to scan the board to find matches. This is the part that took ages to finish, and it's just because it's boring as hell. In general, there are 16 different ways to match gems, and each time the algorithm finds one, it notes down a code corresponding to that move, along with the 2 gems that are swapped to form a match. And if I hop over into MS Paint, let me clear out some space. Yeah, good enough. And here's a full list of each match. You have 2-1 flat, you have 1-2 flat, you have 2-1 flat along the Y, you have 1-2 flat along the Y. A lot of these are just mirror images of each other. You have 2-1V, 1-2V. This also goes for both the X and the Y. Yeah. There is, let's see, crooked down X in either direction, crooked up X in either direction, crooked down Y in either direction, and crooked up Y in either direction. It's not the cleanest system, but again, it'll do nicely for our purposes. And now we get to the part that was completely unnecessary in hindsight, and also ended up taking even longer. Let me see if I can find it. Not make move, get children. Yeah, so down here, I had the brilliant idea, once I was done with all of this, to try and simulate the board, what would happen to the board, basically. Thinking like, oh, what I could do is I could take the board, make the move, and then assuming that everything works, I could have an exact readout of what the board is like, how many gems were cleared, and then make decisions based off of that. Like, for instance, I could sort all of the moves by how many gems that would clear, and then pick the one that cleared the most. That could be kind of cool. But it's slightly broken. Once I get to a future Bejeweled game, or I guess just later, I kind of want to optimize this and make it actually functional. But for now, I still wrote the code, so I may as well go over it. It works about how you'd expect for Match 3 puzzle game code. Scans along the x-axis, or it scans along, let's see, gets all lines of 3 in the horizontal direction, then it rotates 90 degrees, gets all along the vertical axis, then it rotates it back. and then it bubbles up, basically. Whenever the match is found, all of the gems that were matched are placed by X's, because I don't want to be bothered with the random nature of the gems coming in from the top. And the bubble up function will just take those X's and have them flow all the way up to the top of the screen. Now, it's still broken, but it's good enough for my purposes. Finally, now that we have the list of moves, we just pick one and then there you are, we just make the move. And this part was surprisingly easy. I had all the data, all I needed to do was just have it click. That click is actually a click off screen in case it misses a shot so that it doesn't keep clicking the same spot over and over. And then it moves to a position and it does a click and drag to the other position that it needs to move to. So yeah, that ends up working out perfectly. And the last step, I mean, if you think this code is messy, the code down here is even worse. What I ended up doing is I added some arguments. I added first, last, speedy, and stickler. I think that's kind of funny. That change the way that the moves are received. First and last do about what you'd expect. And interestingly enough, first and last causes the system to prioritize moves in the top left and bottom right corner respectively. Because top left is 0, 0, and bottom right is the very last entry in the array. Speedy prioritizes horizontal moves, Stickler prioritizes vertical moves, and I also had it so that Speedy decreased the move delay by a significant amount. It's still not that fast, but it's definitely faster. Let me go ahead and turn that on, and I'll show you what I mean. I gotta freaking... I was trying to put my phone down, but there's something in the way. You'll notice that now, not only is it always picking the first move, but it's also moving significantly faster. However, let's see if it happens. Yeah, there we go. Sometimes it will just make a move that is blatantly wrong, because that's the system getting confused. Pardon me. Ugh. Gotta drink some water so that I don't completely burn out my voice. So there are a few ways that we can improve this a little bit more without going too deep into the weeds. For one thing, we can cheat. Yeah, seriously. I'm not going to do this very often, but if you'll notice, there's going to be a secondary video that I'm going to release alongside this that has 4 different trials of these 3 different modes of a completely random, always picking first, and the speedy. And if you'll notice, there's no text. That's because I deleted the texture files that are associated with the text. And it produced marginally better results, especially for speedy. Speedy doesn't perform particularly well, and that was after removing the text. I wanted to try and help it a little bit, because my initial thought was that would be the best of the 3. Now, again, I'm not going to do it very often, because what's the point of these challenges if I can always make the board look like this? But there are situations where it makes things more interesting or makes it possible at all. Might have to revisit that when I get to alchemy next. Next, we can reduce the delay between moves to be lower. The move delay initially starts out at 0.75, and that turns out to be basically fine. Like I said, we can bring it down a little bit to 0.6, but that ends up causing problems, so maybe 0.7 is better? Who knows? So yeah, cool stuff, right? Based on the video, again, my fast strategy is kind of terrible. The best strategy seems to be a toss-up between the first strategy and the random strategy. I wish I could test it more, but due to the nature of how this works, it's taking 10 to 15 minutes in real time every time I want to test it for time trial, and somewhere between, I think, 5 and 10 minutes if I want to test it in normal mode. So it takes a while. It takes a long time. That was the reason why this got pushed back so many times, is that it took basically an entire afternoon of me sitting there and doing nothing, waiting for this stuff to finish, watching YouTubers play Balatro on my phone, until I kind of just realized that I could record this myself and cut out the editing middleman. Not that there is an editing middleman, but the editing software then. So now we come to the question of how could I improve the code? Well, for one thing, the code is messy as hell. So item one would definitely be clean up the code so it doesn't look like it was written at 11 p.m. on 2 bottles of Monster. 2 bottles. Oh god, imagine if Monster Energy came in like Gatorade bottles. That would be horrid. The other thing, like I mentioned, the board simulation's a bit buggy, and it would have to be ironed out if you wanted to use it for anything. Beyond that, though, it would be really cool to see a full depth-first search where it just goes down the list. You might have seen this for stuff like chess or checkers, where a computer will just go and simulate every possible move, and then every possible move from those possible move states, and just keep going like that to make this massive web. And then traverse that web to find, okay, based on this starting position, here's what I can do, and it gives me the highest possible chance of winning. And in fact, for stuff like checkers, checkers is a solved game. If you have if you have an algorithm that performs that operation, you can just guarantee a win or a draw on every single game. Now, I don't think that's possible with this, but it would certainly be close. If nothing else, it would be you could go 3 or 4 generations deep and then get a pretty good idea of the best move to perform. Maybe I'll do that with a later project, but I'm kind of sick at looking at colored gems, so I kind of want to move on to the colored tablets of alchemy. But this was a super fun project to work on. I've left a link in the description to the source code. I uploaded it on GitHub. Again, it's not exactly job interview grade, but I'm fairly proud of my handiwork. I've also included a link to my Discord, so feel free to join and hang out. There's nothing specific going on there right now, but assuming that more people join, I might start hosting events or something. Also, I mean, if you've made it this far, consider subscribing. I'm planning on doing this for most of the games in PopCap's collection with varying degrees of artificial intelligence. I want to try and incorporate different algorithms as I go along. Maybe I'll whip out the genetic algorithm eventually, we'll see. But I mean, if you want to keep up with that, feel free to hit that button. I'd appreciate it. Well, that's about all I got for now. I did this all in one take, so I'm going to go rest my voice. Thanks so much for watching.